This is Radio TV Phono Nut, and we have a Califone stereophonic record player made for institutional use, probably from around '74 or so. Now let me pull all this apart and show you what makes it a little bit special. Now what makes this special is it'll play 16-inch transcription records, and this is one of the last models that Califone offered that would do that. As you can see, it has the pivoting tone arm like what some of the tube models had, and this tone arm rest got damaged at some point. But this is a model 1155, and Califone continued to offer a model 1155 at least into the 1990s. But shortly after this model was produced, they went to a standard 8-inch turntable platter and a standard tone arm like what you'd see on the little self-contained Caliphones with the speaker on the front. In other words, the newer ones won't play the 16-inch records. Now, I know not many people have a need to play records that size, but there are enough collectors out there who have 16-inch records to make something like this very worthwhile, and buying a radio station turntable that will play those records is often very cost prohibitive, or at least it is for me. I don't have four figures to invest in a used broadcast turntable that'll play 16-inch records. Now the motor runs, but the amp appears to be totally dead, and this plays 16, 33, 45, and 78 and has the variable pitch control, but there is absolutely no sound whatsoever coming out of the speakers, and the cartridge appears to be a static stereo cartridge, which may or may not be good. So let's open this up and see if we can figure out why the amplifier is not working. And here's the underside of the unit. Here's our drive mechanism. It uses a nice big 4-pole motor. It looks foreign made, but I'm not 100% sure of that. Here's our amplifier board, stereo amplifier, and this heat sink was very loose, so I tightened these nuts down. It's not a good sign, because if the heat sink was loose, that means the output transistors weren't making good physical contact, which means they could have shorted and burned up something else in the amp. Here's our power transformer, and notice it has the secondary winding comes out and feeds AC voltage into the amp here, and that's going to be the first thing I'm going to check, is to see if we're getting AC voltage to the amp. And if we are, I'll just continue to dig into this amp until I find the problem. Okay, we have 30 volts coming out of the transformer, so that's good. So now we'll check and see if we have DC voltage on the filter capacitors. Okay, let's check on the first filter capacitor. We have 36 volts, that's good. Now let's move to this second big filter capacitor. Get my meter in here. These things are so cramped up sometimes. And we have Zippo. So we need to look and see what's open between this capacitor and this capacitor. I made a slight mistake. It seems like this set has a dual voltage power supply, a positive voltage and a negative voltage, which means this capacitor will have its plus terminal connected to ground, so we'll want to measure our voltage on the negative terminal, and we're getting negative 4.3 volts. That seems awfully low. So we want to investigate there and see what the problem is. And they were kind enough to provide a schematic diagram in the bottom of the case. Here's C21, and as you can tell, we're supposed to have a negative 20 volts there, and as you saw on the meter, we did not. On the positive capacitor that's in the positive B plus line, we're supposed to have plus 19 volts. we've got about 30 volts, which means something is not conducting and providing the proper load. But right now I want to trace this negative 20 volt line out and see where it goes. And as I suspected, the negative 20 comes up to the audio output stage. So I think the next order of business is to check these audio output transistors and make sure they're not shorted. Okay, I found a problem. We were getting positive voltage here on this filter capacitor, and as you can see, a trace runs directly from here all the way on over here to the collectors of these transistors here. Well, I was only getting about 1.2 volts here and getting a strong positive voltage here, and there's nothing between this but the trace, so that told me that the trace was open. So I just flowed some solder on this trace, and now we have output out of one channel at least. Okay, that channel works, so let's check the other channel. Okay, I'm getting something, but I can tell it's very distorted, which tells me that one of these output transistors is likely not operating. Okay, and a word of caution when working on one of these machines, it's very convenient to have the printed circuit board in this position to work on it. Well, there's a major problem with that. These heat sinks are not at ground potential. They actually have B+ voltage on them, and this metal chassis is at ground potential. So if you have the circuit board in the optimum service position, these heat sinks are going to touch this chassis, and that could be very disastrous. So I have a folded up piece of paper stuck in here to insulate the heat sinks from the chassis so I can work on it. And also be careful with this mounting bracket here. Make sure it doesn't short to anything on the circuit board while working on it. Okay, I found another problem. When I measure the bias voltage between the base and emitter of each transistor, on 3 of them I'm getting roughly 0.5, 0.6 volts, which is about the conduction point for these transistors. However, on Q7 here I'm getting over 1 volt, so that's not right. And that could mean the recipe for shorting a transistor if we're not careful, as well as burning up everything behind it, and I don't really want that. So I'm going to check these resistors here and make sure they're all good. Okay, we have this resistor here that might be a possible problem if I'm checking the right thing on the board. It's an 8.2 ohm resistor. It connects to one end connects to the base, and the other end goes up to this bias diode. It's supposed to be 8.2 ohms. If I'm measuring the right thing, it's reading 54 ohms. So that could definitely cause a problem. Okay, this actually looks like a 7.5 ohm resistor. And we're reading, 53 ohms. So I'd say that one's bad. Now we need to check the semiconductors associated with it and make sure there wasn't any help causing that resistor to go up in value. Although normally when a transistor in one of these shorts, it'll fry the resistor. It won't look nice and pretty. And the 7.5 ohm resistor in the other channel, it's still somewhat working, is actually 38 ohms, so I'm glad I checked that. So that's 2 7.5 ohm resistors that will need to be replaced. Okay, I don't have any 7.5s, but I have some 8.2s, which is what the original schematic calls for. The reason for the 7.5s was likely a revision, but we'll go with the 8.2s for now. That's still way better than what the original resistors were measuring. Okay, it's a new day and we're back on the Califone. Just to recap what's already been done. At first we had a dead amplifier, and that was due to this trace being broken here. I fixed that. And then we had a left channel that was basically almost dead, very weak and distorted. And the right channel seemed to be working, but this right channel audio output transistor was running very, very, very hot. Well, measuring the bias voltage showed me that something wasn't right. And then I found two resistors that were 7.5 ohms each, one in each channel. On the schematic, they're 8.2 ohms, and that's what I ended up putting in there because that's all I had. But you can see one end connects to the base of the audio output transistor, and the other end connects to the anode of this bias diode. Here's one of the 7.5 ohm resistors reading about 32 ohms. That's much, much, much too high. And here's the other 7.5 ohm resistor reading about 52 ohms. Even worse. Now, I checked some more resistors in this set and found several more that were out of tolerance, but that still didn't get us back in business. Our issue now is the right channel is working well, but the left channel is very distorted and the bias is off on it. I'm actually reading about negative 1 point something volts. Let's see what we have here. I swear things keep changing every time I work on this thing. Now we're reading on the bad transistor, or the bad channel, about negative 0.4 volts bias between the base and emitter terminals. When I go over here to the good transistor, the good channel, I'm reading positive about 0.57 volts, which is what I want to see. Okay, looking at the schematic, you'll see a couple of 220 ohm resistors. One resistor connects to the base of the transistor, comes down and connects to another resistor, which in turn connects to the collector. So if I were to check between base and collector of this output transistor, I should read about 440 ohms. Let's check and see what we have there. Okay, on the good channel, that reading is satisfied. On this channel, I'm getting absolutely nothing. So we need to trace this back and find the two 220 ohm resistors and check and see if they're good. Okay, the resistors seem to be good, so now what we need to do is use our ohm meter to check the continuity of these traces from here to here and from here to here and make sure this is making contact, because about all it could be is an open trace. Okay, I believe I found the problem. When I measure from here to here, I get absolutely nothing. So there's a break right here. And like what I did here, I think I'll just solder across that, and that ought to take care of that problem. Okay, that took care of it. And we're reading about 450 ohms across here. So we'll now plug it up and see if our left channel works. Our left channel is indeed working. Now let's measure the bias voltage and make sure it's what it's supposed to be. And then maybe we can call this amplifier fixed. Okay, everything seems to be good. About 0.5 volts between the emitter and base of each audio output transistor. Now, honestly, I think the only thing that saved this amp was probably these traces that were cracked, because with these 7.5 ohm resistors that had gone way up in value, and those helped to determine the bias voltage, with those resistors gone up like they were and throwing the bias voltage on these transistors off, they would have shorted out very quickly. And when that happened, it would have probably shorted every semiconductor device having to do with that channel. It would have been a catastrophic failure, as they say. It could have still been fixed, but it would have been a lot more of a headache, because transistors are not nearly as forgiving as vacuum tubes are. So now we'll put all this back together and see if we can play a record on it. Yeah, we got it working, but it's still going to need some help. As as you can hear, one channel is still weaker than the other. Here's one I missed, a 47 ohm resistor that's reading about 155 ohms. I recall that same resistor in the other channel, I believe it's this one right here, was also bad. So yeah, that could explain the channel imbalance. Here's the 47 ohm from the other channel reading 72 ohms. That's bad enough, but that one reading over 150 is going to have to go. Okay, we're all back together. And our output seems to be equal, and I believe this is going to need a new stylus before long. Here we are with a 78. Here's one of the 16-inch records. Most of these play back at 33 1/3 RPM using the 78 RPM stylus. These were primarily used by radio stations, but once upon a time they were made available to the, shall we say, the general public for the purpose of recording material on them that was often broadcast on radio. Several years ago, I met an elderly lady whose husband was a preacher during the 40s and 50s, and he passed away during the 70s. And back during his heyday, all of his sermons were cut on these big 16-inch records at a local radio station, and he had a transcription player to play them on. And the old one she had was an old Califone from back in the 40s, and it was way past going, and I found her something else. But anyway, here you go.
The United States Treasury Department presents Guest Star with Frank DeVol's orchestra, yours truly, John Conte, and starring Dinah Shore. How do you do, ladies and gentlemen? This is John Conte, your host for Guest Star, a transcribed feature for savings bonds presented as a contribution of this station in the public interest.
Okay. So yeah, we have a few more things we'll need to do on this at a later date. I want to tear down the drive mechanism and give it the usual cleaning and re-lubrication. And it's probably going to need a new cartridge sometime in the near future. I can tell this one's kind of on its last leg. But there you go, the Califone 1155 stereo transcription player from 74. A whole bunch of resistors later and some new capacitors, and we're back in business. Alright, there you go. More to come later.